Good morning, grade 3. Today we are going to continue with lesson 2. How does energy change form? Textbook pages 364 to 365. Yesterday I have explained about different forms of energy and how energy can change from one form to another. Today I'm going to explain the ways that energy travels. Ways that energy travels. Energy can travel from one place to another. A moving object carries energy. For example, when this man hit the baseball, the energy passed from the man's arm to the baseball bat and then to the baseball. When the boy tried to catch the ball, he can tell how much energy the ball has by how hard it hits his hand. If the ball hits slowly, then the ball carries less energy. If the ball hits hard on his hand, then the ball carries more energy. Energy can travel as waves. Have you ever seen waves of water? Look at the picture here. This is a water waves. This waves also carries energy as the baseball does. These waves of energy have the same shape as the waves of a moving rope. Look at the rope in the picture. What caused the rope to travel from one end to the other end as waves? It's energy. Energy caused this moving rope to travel from one end to the other end as waves. The rope itself cannot move forward unless there is energy acts on it. Light and certain other forms of kinetic energy moves as waves. Waves in water can be small, but waves caused by hurricanes can be huge. How big the wave is depends on how much energy it carries. So if the hurricane waves are huge, then the energy carried by the waves is more. When you throw a stone on the water, you see small waves. These small waves carries less energy. Parts of a wave. We can measure the amount of energy that a wave carries. There is two ways to measure a wave's energy. One way to measure a wave's energy is by measuring the distance from the midpoint of the wave. Another way to measure a wave's energy is by measuring the length of the wave. Let me explain you how to measure a wave's energy. Now look at the picture of the wave. Bottom of the wave is called trough. Top of the wave is called crest. The line that divides the wave into two is called midpoint. This is the distance from the midpoint and the wave. The distance between one crest to another crest is called wavelength. Now, if you see the distance from the midpoint of wave is small, and if you see the distance between one crest and the other crest is nothing but wavelength, if you see the wavelength is more. So, when the wavelength is more and the distance from the midpoint of wave is less, then the energy is less. If you see the waves are wide from each other. So the wave carry less energy. Now in this picture, if you see the same, you have crest, you have trough, you have distance from midpoint of a wave, you have wavelength, you have midpoint, everything. Now look at the wavelength, that is distance between one crest to another crest is very small. But if you see the distance from the midpoint of wave is more. And if you see the waves are very close to each other. When the waves are very close to each other, the wavelength will be less and the distance from the midpoint of wave will be more. It means the wave carries more energy. In this slide, if you see the first picture, this is a wave with low energy because the wavelength is more and the distance between the midpoint and the wave is small. But the second picture is the wave with high energy because the distance between the wavelength is less and the distance from the midpoint and the wave is more. So this is a wave with high energy.